So the next problem is just kind of something tricky that can happen. First off, if I start grouping with this 4-term polynomial, there's no GCF on the first two, and there's an x on the second two, and I can tell that if I took out a 1 here, and maybe a negative x here, and got a plus b, that's not going to help me out. So sometimes, rarely, you do have to reorganize the terms. So I'm actually going to rewrite this, and I'm going to try switching these two. Let's see what happens. So I have x squared minus ax plus ab minus bx. So let's see what happens with that first. So we're rewriting. We haven't changed anything, just commuted a couple of those. So I take out an x. Here I take out a b. And that's going to give me a minus x. So that's not really what I want. So, but I notice it's backwards of what I want. So I'm going to take out a negative b. And that's going to give me a negative a and a positive x. So that looks pretty good. If I just switch these two, right, which is legal, right, we can add in the opposite order and write x minus a here. And I'll copy down the rest of it. Now I have a common binomial factor. So I can take out my x minus a and my x minus b. So I kind of did this one wrong. I was initially just supposed to rewrite. And then this is write it as the expression as an equivalent product of binomials. This is a product of binomials, so that's the second part. Our next little thinking question is something that can happen. We like it when we see 4 terms to think that grouping works. So if we had an expression like this, 2x cubed plus 10x squared plus 7x plus 21, it looks like we should be able to factor it, right? It looks like 4 terms. But if you take out the GCF here of 2x squared, this is what you'll get. And if you take out a GCF of 7 here, this is what you'll get. So this person was like, it's not quite right, but I'm going to make it work. So they decided to add these two together because they didn't match. Okay? We can't do that. The binomial has to match to take it out. Okay? So this one we would actually say is not factorable. Okay? And we would say there is no common binomial factor. So I can tell that's incorrect. Something else I could do to check it is if I plugged a number in here, like if I plugged x equals 5 in here and x equals 5 in here, we would not get that they were equal. And anytime we factor, the original has to be the same thing as what we end with.